Deep Pathology Studio, bringing the power of AI to pathologists. In this tutorial, we will go over the basics of the cell detection mode. The cell detection mode lets you create powerful AI algorithms for detecting and classifying different types of cells. We will also introduce a few new concepts: the powerful gallery annotation mode, active learning, and auto AI annotations. To start a new cell detection project, click on the Cells button in the home screen. Then, select the project directory location. To add slides to the project, click File, Add Slide to Project. You can add as many slides as you want, and do this at any time. You can pan by dragging and also zoom in and out using the mouse scroll wheel. In this tutorial, we are going to create an AI algorithm to detect the red blood cells. In the cell detection mode, you can annotate cells inside the viewer, just like in the Objects mode. Or you can annotate in the powerful Annotation Gallery. Let's go to the gallery. Click on the Annotation tab on the top menu. You can give names to the categories and add up to 9 categories. The first category is Background. It is always what you don't want to detect. After a few seconds, you should see many cells appear in the gallery. A deep learning algorithm is running over the slides and detecting the locations of objects that look like cells. For every detected cell, a small image is cropped around the center of the cell. This is what you see in the gallery. Now, we have to teach the AI how the different categories of the cells look like. In this example, we are going to annotate the big red blood cells as the second category and everything else as background. You can click on a cell a few times to change its category. You can also select a cell with the keyboard and press 1, 2, 3, and so on to select the cell category. You can also choose to ignore a cell if you're not sure about it. To do that, press 0 when the cell is selected, or click on it until it has a white color. To navigate between cells, it's recommended to use keyboard arrows. As you can see, it's really fast to annotate this way. Once we have a few cells annotated from every category, we have an AI algorithm that starts to learn in the background. You can continue to annotate while it's learning. We can keep track of different graphs and metrics to see how the AI training is going. Let's switch to the Graphs tab above. Here, you can see the accuracies for the different categories. The orange graph represents the total error of the algorithm. With time, if everything is okay, it should go down. The rest of the graphs should go up. Sometimes, you might want to see more context around a cell in the gallery. To do that, right-click on the cell. It will jump to the viewer to the location of that cell. Next, let's see how we use active learning to accelerate the annotation process. When you scroll down in the gallery, the studio is selecting the next cells you should annotate to be able to improve the AI the most. There is an algorithm that selects for you the best cells for annotation. It is based on a technology called active learning. In our case, so far, we annotated many background images and not a lot of red blood cells. This often happens. The cells you want to find might be rare. So the studio is giving priority to annotating red blood cells. This gives us an opportunity to quickly annotate many examples from the rare categories. Can you see how many of the images in the gallery are red blood cells now? This is thanks to active learning. Now, let's quickly annotate a lot of red blood cells to get a more balanced data set. When the AI is accurate enough, it's going to be a lot more efficient to just use what the AI guesses as an automatic annotation and just correct it when it's wrong. To turn on the AI mode, click on the AI mode button on the left. Now, when you scroll down, you can see that the new cells have their label set automatically. All you have to do is click on the cells that are wrong to correct their label. You can scroll down. The studio will select the best cells for annotation and also automatically set their label for you. Let's see the AI in action. To run the algorithm on a selected field of view, click on the Run button on the left. You can see the detections on the screen. To add a detection to the training data, you can right-click on it. This lets you add many cells to the training data by running the algorithm and right-clicking on the results. To change the category of a cell, you can press 1, 2, 3, and so on. You can also annotate cells directly in the viewer. When you are happy with the performance of the AI algorithm, you can go to the Settings window and click on Freeze on the left. This will stop the learning process, and the model will stop changing. You can then run the model on slides to create reports with the cell counts inside them. Overall, it took us about 2 minutes to annotate a few hundreds of cells, have enough data from both categories, and create an AI that's already pretty accurate. We think that's pretty exciting. What will you annotate with the cell detection mode? For more information and to book a live demo, contact us at info@deeppathology.ai.